Hey Leslie, higher order roots. You are exactly correct. What we do is do a prime factorization or factor tree on this because most people don't memorize perfect cube roots. I certainly don't expect you guys to. Maybe 1 to 5, that would be about it. But as you do these, you'll kind of pick up on them anyway. So what we do, take any number and we take it right to prime. So 24, I'm going to go 4 times 6. You could do it any other way. 2 times 12 works. And take it right to its prime number. So that's 2 times 2 times 2 times 3. And notice that the index here is 3. We're looking at a cubed root. So what I'm going to do is I'm going to pick 3 of my multiples. So I'm going to rewrite this. I'm going to rewrite this as the cubed root of 3 cubed. That's right here, sorry. 2 cubed. 2 cubed, like so, times the cubed root of 3. That's just this other guy right here. So remember, we still want something that kind of equals 24. I'm just grouping it up in such a way that I'm going to be able to solve this. So the cubed root of any number cubed cancels. It all goes away. So when the index and the exponent are the same, they just go away, and our answer here is 2. The cubed root of 3, there's no rational answer for that. If you blast that into your calculator, if your calculator will do that, you're just going to get a decimal that goes on forever. So just leave it as is, so it's going to be 2 times the cubed root of 3. There we go. So whenever you can evaluate like this is a number, this is a perfect cube, away we go, just list that number first, and then always just smack it on with the rest. Let's take a look now at our next one. Same play, 49. I have no idea. 49, so let's think about 7 and 7. That's not really going to help us. So what we can do is, instead of factoring this out, like 49 and 28, as you can see, I kind of hit the wall. 49 is 7 and 7. That doesn't give us 3 numbers, right? 7 is a prime number. So what we're going to do instead, we're going to multiply these together, okay? So the number underneath the square root sign is called the radicand, or the radicand, and we can still keep everything under that cubed root, but we can multiply it together. So we have 49 times 28. I have no idea what that is, so I'm going to pull out the old calculator. That's going to equal 1372. Okay, now it's the same play. We're going to do a factor tree on 1372, which is going to be quite a big one. But now I'm just coming up with 2 numbers that will equal 1372. And I mean, you could do 2 right here, so half of 1372. Let's divide that by 2. 686 times 2. We'll do half of 686. That's going to be 343 times 2. And then 343, let me clear all this. 343, let's divide that by 81, because that looks familiar to me. 343. That didn't work. Let's try 9. No. So what I'm trying to think of is like numbers that are cubed, right? It's going to be probably a big one here. 343. Let's go 11. No. Struggle's real, guys. Struggle is real. 343. So instead of guessing now, what we're going to do, we're going to hit the internet. Online course, so it's okay. I'm going to ask Mr. Google, 343 factored. And yes, you can do this if it's a huge number. That's fine, right? But don't do it every time, obviously, right? They keep going on that one. There, we want the prime factorization. 343. 7. There it is. 7 cubed. So that's beautiful, right? That works for me. So 343, that's going to go 7 times 7 times 7. So this whole deal, this whole number right here, if we think about this, we have our three numbers, because we're talking perfect cubes here, and we have these other 2 numbers, 2 and 2. Okay? So let's rewrite this now. Let's rewrite this whole mess as the cubed root of 7 cubed times the cubed root of 4. Essentially, right? 2 times 2 is 4. I'm just going to multiply them back under here just to save some space. So there she is, really. Now what we can do, we can evaluate this because that's going to be just 7, right? Again, the index and the exponent are the same, times the cubed root of 4. And there we go. Okay, so hope that helps. That's a huge number, but that's pretty much the struggle, buddy. Do a prime factorization. If you get crazy things like that, hit the internet. Don't kill yourself doing that. But know how to do it. Don't hit the internet. You know, if you're looking at like the cubed root of 8, don't internet that. Okay? The internet might make fun of you. But I hope that helps. Let me know if it doesn't. Take care.